Hello everyone, welcome back to my channel. So now we are in the day 112 and as I have highlighted again the point synthesis, modification and characterization of the selected photocatalyst. So we'll continue the same. Now today my major point is to explain you that how to insert figures in your slide, how to represent them in your slide with the help of one characterization method, that is FESEM, field emission scanning electron microscopy. So we'll discuss this in this dosage. And what I want to explain you is that after including all these pictures, all these figures, how you can compare different aspects like particle size, agglomeration tendency and morphology and many more depending on your project. As I have told you earlier also that this is a case study. So I did that. I have compared particle size, agglomeration tendency and morphology. So one thing that you should keep in mind when you want to show something through your figure, compare two figures, you have to insert them as A and B. Okay, parallelly you have to insert them. And second point, the figure should be of same resolution. Suppose you have to compare the particle size and आपके दोनों figures अलग अलग resolution के होंगे, then it doesn't make any sense. So you have to keep the resolution same and then you have to compare. Okay, so as you can see in my figure X, FESEM images of prepared TiO2 powder as A. What is A? The TiO2 nano powder prepared at pH 3.5. This you have to mention very accurately. The caption, as I have told you earlier. In B, you have to just insert the figure of the TiO2 powder that was prepared at pH 9.5 and then C at pH 12.5. Now you want to compare, okay, you have to compare the figures of these three pH. So keep the resolution same so that you can figure it out that what are the changes that has been observed at different pH. So in notes I have written that as per observation, you have, as I told you earlier, that you can add one or two sentences in your notes, that as per observation from the above images you have to write, particle size increases with increased pH. So what is my result? What is the conclusion? That particle size increases. So you have the proof also, you have the justification also, that as the pH is getting increased, okay, your particle size is also increasing. So just you keep in mind that you have to insert your figures parallelly so that audience can see it properly, and you have to use the same resolution. Okay, the conditions should be same. Then only you can figure it out. Similarly, in figure Y, what it indicates, FSM images of prepared TiO2 nanoparticles. Now you can see it. The caption, just see the caption, how the caption is written. A, as prepared, okay, without any modification. That means without any modification. B, 600 degrees Celsius, means the calcination temperature is 600 degrees Celsius. In terms of agglomeration rate. Okay, now you have to see the agglomeration. You have to compare these two images and you have to see the difference in the agglomeration rate. That how the agglomeration rate is proceeding by changing the calcination temperature. First one, A is, your first figure is as prepared and figure B is calcined at 600 degrees Celsius. So what is the result? You can write it in your notes. As per observation from the above images, agglomeration tendency decreases as the sample is calcined at higher temperature. Because what happens, now you have to just think also that why it is happening. Okay, this is happening, you have justified also, but why this is happening? So anyone can understand this concept. क्या होता है जब आप किसी पाउडर को बनाते हो, नैनो पार्टिकल्स खास करके, तो उसमें क्या होता है, पार्टिकल साइज जो होते हैं, पार्टिकल्स जो होते हैं वो एक दूसरे के साथ स्टिक हो जाते हैं बिकॉज ऑफ द मॉइस्चर. और जब आप उसको 600 डिग्री सेल्सियस पर कैल्सीन करते हो, उसमें हीट प्रोवाइड करते हो 600 डिग्री सेल्सियस, तो उसमें से मॉइस्चर हट जाता है, मॉइस्चर गेट्स रिटेन्ड, तो फिर पार्टिकल्स अलग अलग हो जाते हैं. तो ऑब्वियसली एग्लोमरेशन टेंडेंसी वो डिक्रीज़ होगी. तो आप बस जस्टिफाई ही मत करो उस चीज़ को, बस उसका प्रूफ मत ढूंढो, उसके साथ साथ अब थिंकिंग कैपेबिलिटी भी बढ़ाओ. ओके, इट इज़ जस्टिफाइड बट वाई, हाउ, ये सारी चीज़ें पूछो. ठीक है, एंड जब आपको क्लियर होंगी तभी आप एक्सप्लेन कर पाओगे ऑडियंस को. ओके, नाउ नेक्स्ट, in next slide you can see figure Z, FSM images of prepared TiO2 nanoparticles. A is as prepared. As prepared means the way you have prepared, you have not modified it. So why I am putting as prepared in every slide? Because you have to compare this as prepared TiO2 nanoparticles with the modified ones. So first one should be as prepared. Now what is point B? It is calcined at 600 degrees Celsius. And why we are just using this slide? What we are doing in this slide? We have to compare the particle size and morphology. Okay, what is the shape? You can say what is the shape of that particular powder after doing FSM. Because what FSM stands for? Field emission scanning electron microscopy. As we scan any document, likewise we scan our prepared particles in this FSM. You have that equipment, so we use that equipment, we take the slot and go, and in the sampler we used to put that. So after all the analysis, they used to give you the images. Okay, images, and by using those images you can just find out these properties. So all the images that you can see in my previous slide, they are efficient images. So in this also you can see how to write the notes, that as per observation from the above images, particle size increases as the sample is calcined at higher temperature. Okay, particle size increased as the sample is calcined at higher temperature and exhibit nearly spherical morphology. It has spherical morphology. So morphology means shape. This is spherical morphology. It has spherical morphology. You can also browse and see different type of morphologies. So this is a case study. You can just adopt this thing in your project to insert the figures, how to insert the figures. So I hope you understood my point. What in this dosage, what we have discussed, that according to my case study, we have compared the particle size, agglomeration tendency and morphology of my prepared TiO2 nanoparticles. So इसी तरह से आप इस कॉन्सेप्ट को अपने प्रोजेक्ट में यूज़ कर सकते हो. बस आपको ध्यान इतना देना है कि जब भी आप फिगर इंसर्ट करो तो सेम रिजोल्यूशन का फिगर हो, बिल्कुल क्लियर इमेज आ रही हो, कैप्शन सही से डाला हुआ हो और सेम कंडीशन पे हो, तभी आप किसी चीज़ को कंपेयर कर पाओगे. ठीक है, तो सो टिल देन वर्क हार्ड. थैंक्स अ लॉट.